Hello, this is Shudanshu Sarkar, Assistant Professor, Department of Electrical Engineering, Narula Institute of Technology. So, the subject is circuit theory and networks, and my today's topic is source conversion. So now the question is, what is source conversion? For circuit analysis, or to solve any circuit, to find the current, voltage, resistance. So for these types of mathematical calculations and analysis of circuit, sometimes we have to convert this source. So this is very important topic, and the topic is called source conversion. That means, so what is actually the sources? In normal cases, we know that we have two types of sources. One is voltage sources, one is current sources. So here we are going to convert this voltage source to current source, or current source to voltage source. Now, many times when we are solving a circuit or a problem, it is quite difficult to solve it by using same source which is given in the problem. To make it easy, we convert our given circuit. And sometimes current source can be changed by a voltage source and vice versa. But we have to fulfill some necessary condition. So I'm going to discuss on that condition. The first one is type of source conversion. I already told that number one, current source to voltage source, and number two, voltage source to current source. So these are the two types of source conversion we have. So here I am going to discuss first current source to voltage source. A current source can be converted into a voltage source if and only if a resistance is parallel to the current source. The circuit is given below. In the left hand circuit, we can find that we have a current source, and here the resistance is parallel with the current source. So what is the condition? The condition is the current source can be converted into voltage source. That means to convert from a current source to voltage source, the basic requirement is if and only if a resistance is parallel to this current source. So here it is in parallel left hand side. We know that this is the current source and this is the voltage source. So with the current source, resistance is connected in parallel. So here we can convert it from current source to voltage source. So for voltage source, so this current will be converted to voltage. As per Ohm's law, we know that V equals to IR. And here, if we convert current to voltage, so voltage will be there and this resistance, parallel resistance will be connected with the voltage source in series. So this is the method. Now, current source to voltage source calculation. Current source is converted into a voltage source in which a parallel resistance R become in series with the voltage source. So we find it in the last figure. So with the voltage source, the resistance is connected parallelly. And the voltage value of these voltage source is equal to V equals to IR. Very easy. It is the equation we form it from using Ohm's law. Here the direction of the voltage source is depends upon the direction of the current source. So we need to remember this specific line. So the current direction will be same as the current source, the voltage direction. The voltage source can be converted into current source if and only if. So this is actually the vice versa method. In the first method, we find that current source convert into voltage. So here we are converting voltage source to current source. The voltage source can be converted into current source if and only if a resistance is in series with this voltage source. So if a resistance connected in series with the voltage source, that condition you can convert it to the current source. So what will happen? The same. So here the current source will come and the resistance will connect in parallel. will be connected parallelly with the current source. So this is actually the conversion. So the value of the current, we also get it from Ohm's law. As per Ohm's law, V equals to IR. So here I equals to V divided by R. So in this way, we can convert voltage source to current source and current source to voltage source. Now, the second important topic for circuit analysis is the voltage division rule. So voltage division rule is applied on a circuit for finding individual voltage of an element or a resistance. So why we use this voltage division rule? Is applied on a circuit for finding individual voltage of element. That means we have to find the voltage across resistance 1, voltage across resistor 2, and voltage across resistor 3, that is R3. So if we have the requirement that we have to find the voltage across the element, then we need to apply this voltage division rule. So what is voltage division? Suppose that 3 resistance is R1, R2, R3 as per the figure are connected in series. So here it is connected in series with a voltage source V. So here the voltage source is V. Then so that the individual voltage V1, V2, V3 finding is our requirement. So what is V1? V1 is equals to V into R1 by R2 plus R3 plus, sorry, V1 equals to V, that is the source voltage, into R1, the element where we are finding the voltage. So supply voltage into that element R1 divided by the summation of all the resistance of the circuit which is connected in series. So R1 divided by R1 plus R2 plus R3. Look, as per the figure, so if we are going to find the voltage across R1, then what is the equation? V1 equals to source voltage into R1 by R1 plus R2 plus R3. Then V2, same way, V equals to V2 equals to V into R2 by R1 plus R2 plus R3, and V3 equals to V into R3 by R1 plus R2 plus R3. So in this way we can find the voltage of individual element, and this is called voltage division rule. So we can define this voltage division rule like unknown voltage of a resistance is equal to applied voltage, that you already find the equation. So from the equation we can write the formula that unknown voltage of some resistance equals to applied voltage into resistance for which voltage is to be calculated divided by sum of all the resistance. Clear now? Voltage division rule is only applicable for that circuit in which resistance are in series with a battery source. You have to remember this line. Yes, now we are going to understand what is current division rule. Current division rule is applied on a circuit for finding individual current of an element or a resistance. Suppose that two resistances R1 and R2 are connected in parallel with a current source I. So the individual current I1 and I2 are given by, look, so I1 equals to I into R2 by R1 plus R2. What is I? I1 is, what is I1? I1 is the current which is flowing through R1. So here the formula is I1 equals to I is the source current. So I divided by R2 by R1 plus R2. But what is R2? R2 is the opposite resistance. Look here, I1 is flowing through R1, so opposite resistance is R2 from when I2 is flowing. So I1 is equals to source current into opposite resistance by total resistance R1 plus R2. So the equation of I1 equals to I into R2 by R1 plus R2. I1 equals to I into R2 by R1 plus R2. So in the same way, I2, what is I2? I into R1 by R1 plus R2. Here it is same, I into R1 by R1 plus R2. Now current division rule. So unknown current of the resistance is equals to total current at that point into opposite resistance by sum of the resistances. And for this particular formula, we have to remember current division rule is only applicable for that circuit in which two resistances are in parallel with a current source. Current division rule can be used with a current source as well as voltage source. Now this is the reference, and thank you all.